Against? Carried. Thanks very much again. And I'll now, my pleasure to call up our second major presentation here today from China Rail. And I think we have a number of presenters in the team that are coming up. I don't know if it's Wong who's doing the introductions and the presentation. I'll leave that over to you. And as you can see, this is to do with the trackless tram technology, and our guests have flown over from Australia. So welcome to Auckland Council. Thank you very much for this presentation, and as with the last one, we're certainly looking at it with more than just a passing degree of interest. So over to you.
Okay, thank you, sir. Ladies and gentlemen, good morning. We are from CRRC, and let me just introduce a little bit about CRRC. CRRC is a solution provider from China, which means that we are not only a car builder, we are also providing a series of services to our customers. So before I can start, I would like to deliver a presentation about the trackless tram, a kind of solution we are proposing from China. And maybe let me just give you a small video presentation so that you can have an idea about what DRT is.
CRRC Nanjing Pujian Company Limited, as a first-class subsidiary of CRRC, owns a series of core design technologies, including, but not limited to, EMU, urban rail rolling stocks, passenger coach, modern trams, monorails, APM, suspended SkyTrain, etc. We have been and continuously contributing to the wisdom and strength of CRRC in the frontier fields of world rail transit. We keep continuous research and innovation in energy application frontier and successfully complete the upgrade of Digital Rail Rapid Transit Vehicle. Digital Rail Rapid Transit System is referred to as DRT, which is a brand new vehicle system with many advantages. DRT is designed according to the characteristics of urban roads. The width of the DRT vehicle is 2,500 millimeters. The maximum axle load under AW3 is not more than 7.5 tons. The maximum climbing slope is 15 over 1,000, and the vehicle has a maximum turning radius of 15 meters. DRT mainly uses the electromagnetic tags of the magnetic nails embedded in the road and integrates optical detection, satellite positioning, and insertional navigation correction to form a highly reliable multi-dimensional digital track. It is not affected by the environment and can achieve very high reliability. The vehicle can achieve a variety of safety and protection functions, such as speed limit control, obstacle alarm, and car body posture correction, and provide the driver with various auxiliary operation information, such as target speed, automatic station announcement, and lane offset. The DRT adopts supercapacitor or hydrogen fuel cell as the onboard energy storage, which is environmentally friendly. No catenary is required above the line. The vehicle itself has low energy consumption, low operating noise, no impacts on environment. When using supercapacitor for onboard energy storage, DRT can run more than 30 kilometers under AW3 load. It only takes 15 minutes to be fully charged. Charging can be carried out by pantograph charging or charging pile. The hydrogen fuel cell used enables DRT to operate continuously for 150 kilometers after hydrogenation for 15 minutes, and the hydrogenation system can work with commercial hydrogenation stations. DRT system is equipped with intelligent train control and management system, which realizes functions of vehicle control, driving assistance, event record, fault analysis, maintenance assistance, and so on. The driver's cab is equipped with an intelligent display unit that can display information such as vehicle working status, subsystem equipment health status, real-time monitoring, and abnormal behavior judgment of drivers and passengers. DRT is also equipped with panoramic surround view, radar protection, and other functions, which can help drivers monitor the vehicle operating environment in real time, realize obstacle detection, and ensure driving safety. DRT does not require any physical tracks. No catenary is required above the line. Any common roads can be used by adding electromagnetic tags. The vehicle supports bidirection. Driving these design greatly reduces the project investment. The life of the main structure of the vehicle is basically maintenance-free within 30 years, and the maintenance requirements of the subsystem components are low. Therefore, the number of maintenance personnel and the scale of site use are greatly reduced. DRT adopts digital track for guidance. The construction of magnetic nails is very convenient. The line and station can be adjusted flexibly, and the manual driving mode is retained to meet the needs of lane change and line change operation. Digital rail vehicles are available in 2, 3, and 4 formations and can be customized according to requirements. Large-size air springs are used as secondary suspension, and rubber wheels are adopted to reduce noise and achieve high comfort. The gap between the vehicle and the station is narrow, and the floor height on the vehicle is the same as the platform, so that passengers can get on and off the vehicle without barriers. The vehicle riding comfort performance can reach the level of rail transit. 2021 UN Climate Change Conference makes comprehensive efforts to promote the energy system to low carbon and carbon-free fossil energy. We will also continue to bring more green products.
Okay, thank you. So, this video shows our operation of the DRT fleet in Shanghai. And after that, I would like to deliver a small presentation about CRRC, about our DRT solutions. So maybe we shift to the presentation. Okay, so we call it DRT. We call it a route-based mass transit. So let me introduce a little bit, maybe several sentences about CRRC. CRRC is one of the leading solution providers from the world for rolling stock and in the railway business. So the mission of CRRC is connecting the world through better mobility. And through the years of development, we have secured the goals of ESG in the worldwide through providing a series of high-quality products. And up to present, CRRC has the total employees of more than 170,000. And under the umbrella of CRRC, there are 46 subsidiaries. And we are CRRC Nanjing, and we are also one of the subsidiaries under CRRC. And when we are talking about DRT, one point we would like to highlight is passenger volume. So there are several modes of transportation solutions, like as far as we know, metros, trams, and DRTs also. And the reason why we would like to highlight is because we highly recognize DRTs are a very good solution in the cities like Auckland and also many other cities in the world. DRT is called Digital Rail Rapid Transit, and it is a combination of rail technology and automotives. Because first of all, it is rubber-tired, so it seems that it is a bus, but actually it is not, because everything here is based on railway technology, and also DRT is more flexible, considering that there are 3-car, 4-car, or 2-car formation depending on the passenger volume. And the reason why we would like to introduce DRT because we already have the routes in all the cities. So the routes are also ready to be used. So that is the reason why we would like to say that the DRT will be more suitable for, the cities that is, let us see, the cities that with a lot of population, and also for the cities that is very, very difficult to make a lot of changes. So the maximum speed of DRT is 70 kilometers per hour. And because the minimum lane width will be 3.5 meters for the DRT to operate, so all the routes will be suitable for the DRT to operate up to current. And the DRT is a kind of a self-navigation system, because we just install the magnetic nails onto the ground, and that's all. And the DRT will simply follow such a kind of system formed by the magnetic nails. So it is a kind of self-navigation system. And because it is also rubber-tired, I just, these days we also visited the city of Auckland. We can see there are a lot of gradings. And because it is rubber-tired, and because of its low axle weight, axle load, so the DRT vehicles are able to climb up the very high slope gradings, because its climbing slope, as you can see, it is 15%. In terms of power supply, there are two kinds. The first one is we can use supercap. The other one we can use hydrogen. Both of them are already available in worldwide, especially for the power supply, electric power supply. And as for operations, because some of the routes will be very narrow, so the stations can be placed beside both sides of the roads. And if the roads are big enough, are wide enough, the stations can be placed in the middle of the roadways. And before I finish, you can see the pictures of the references we have. The first three ones are the DRT fleet we have now in Shanghai, and we also secured other projects in Monterey, in the country of Mexico, and up to present we have lines for over 50 kilometers up to now. And last year, we also have a demonstration in the city of Stirling in Australia. And we placed one vehicle in Australia. And we also received a lot of very positive feedback from such a demonstration. So finally, I would like to highlight some of the advantages for DRT. The first one is because we use electric power, and also we can use hydrogen, so it is environmentally friendly. So secondly, because it is rubber-tired, and also it is running on the existing roadway, so its adaptability is also more flexible. The third one is because we use the railway standards, so its comfortability will also be better, because as I just introduced, there are the air springs, so that the passengers can receive very, very good ride quality. And also it is more safe, because we just consider the rescue requirements. So once the DRT vehicles are running on the roadway, once there is any accident, for example, these are ready for rescue at any time. And also it is a kind of self-driving, driverless, self-navigation system. So that is I want to introduce. Thank you.
Thanks very much, Wong, for your excellent presentation there. We'll open it up to questions from councillors around the table. We've got Councillor Darby, Councillor Filipina.
Thanks for bringing these ideas, the second one today. Appreciate it, and welcome to Auckland Council. Can I just ask, the actual loading at, I think in your presentation it said 6 tonnes, and then orally you've said 7.5.
So
how does that compare with an articulated bus? I'm just trying to get a sense of how different this is to how an optically guided so-called trackless tram or what you're proposing is different to an articulated bus in terms of loading. And also, could you just describe what surface needs to be constructed to take care of that loading, which is in the same line all the time? Because we are aware that where we've got big buses, double-decker buses, they put immense load in one particular location. And last question, quickly, one of the things about rapid transit by rail or busway is it's a set route, and the development that responds to that route does it because it knows that that route's going to be there for 50, 80 years. So around the question of flexibility, what about the question of permanency to stimulate development response because they know the route is going to be there and it's not so flexible as it's going to be in another part of town anytime soon? Thank you.
Okay, thank you. So before I answer this question, I would like to introduce our team. So Steve from Becca, and also Brian from Transit Next. And Nadia and I, we are from CRRC. So these days, we also went through all the routes the current bus fleet are running. And as far as we can say, all the routes which are suitable for buses, they are already suitable for DRTs because the actual load of the DRT is just the same as buses. Because the DRT we are proposing to Auckland, it is 6.5 tons. It is just the same as the buses and also the double-deckers. So which means that it will be just the same or even be lighter. That is one thing. For another, we will install the magnetic nails onto the roads, and that's all. So which means that once you have the roadways suitable for buses, we just install the nails onto the ground, and the DRT vehicles will just follow the path formed by the nails. And also for the surface life, the DRT's the surface life is 30 years. So that this means that they are suitable for a longer service life compared with the buses and the BLTs. Yes.
Okay, thank you, Councillor Filipaina.
Sorry, you have a question about regeneration. Yeah. The whole system's designed for that. All right. Sorry, into this.
Yeah, push talk.
Oh, push talk, great. Sorry about that. The whole system's designed for regeneration. So city regeneration. If you go to our website, www.transitnext.org, you'll see a lot of articles written by Dr. Peter Newman on that. So it's about regenerating cities. You want to be a smart city, you use this technology. Thank you.
Councillor Filipaina.
Ni hao, 谢谢你的欣赏. My question is, have you identified any areas within Auckland where you could begin with?
Yes.
We just investigate all the routes, and we can see that from the airport to Botany, it will be one of the suitable routes because considering the very big passenger volume, and we can see that some part of the areas, like from Auckland Airport, there is something under construction. We can know that there will be a lot of more passenger flows. And one thing we also learned that even for the airport itself, there are 23,000 employees. So we think that the routes, for example, Albany and Botany will be the routes that our DRT vehicles can operate. Yes.
Just answer to that. We actually met with AT earlier this week, and they mentioned to have a look at the Albany busway. So we went from Akaraa to Albany, and we looked at that, and Becca has suggested the stadium for a storage area. We went to actually where the buses were, and Mr. Wayne picked up the electrical charger. I had to clean the cobwebs off it, because obviously someone hasn't used it, but it's exactly there. So the infrastructure's built. Thank you.
Councillor Simpson.
Yeah, that's interesting. Thank you for your presentation. What is the capital cost of installation? In other words, can you give us confidence it's cheaper than a track-based variety? That's my first question. And my second question is, I'm just trying to Google desperately Stirling in Australia, which you're going through some testing at the moment. And I was going to ask you what that cost and how that testing is going.
So the capital cost, because we should do some further investigations because before we can get a specific figure. But let us say that the cost will be 1/3 of the tram systems.
Just to answer that question, we have already come prepared. I've got a German infrastructure fund who will provide the funding. We've got 2 other sources. So it's a matter of whether we roll it out in Auckland or Wellington, who wants to be first. So basically it's up to you guys. We've spoken to various ministers. They just said it's up to council. So we can install it within 6 months.
And what was the Stirling cost?
The Stirling cost, that's not my area because I'm only interested in New Zealand and mainly Auckland because I don't want to get up at 5 o'clock to get into town at 9 o'clock and sit on the motorway. This system will get rid of congestion. So 1 lane of trackless trams takes off 6 lanes of motorway. Yeah. But obviously motorway's NZTA, so we'll have that discussion which we've had. The costing, you'd have to talk, we can get you that for you through Curtin. Because Curtin's part of our team. Sorry.
We'll follow up on that one then.
Sorry, Brian, can I just add to that? So what Australia wanted to do was to effectively to look at the vehicle and to determine. So it was brought over by the university, Curtin University, and they wanted to actually certify the vehicle to operate on Australian roads. That was part of that. It was also for technical people to get around and determine, understand all the questions, which is one of the things that Transex and CRC want to do. They want to bring the vehicle to New Zealand, so effectively you can look at it and actually trial it on the roads and understand those questions that have been asked around impact on the roadway that Councillor Dolly has asked. But the reason for going to Curtin was effectively to understand how it would operate on Australian roads and to certify it, which is a similar thing that we'd have to do in New Zealand as well to make sure the vehicle could operate.
Just on certification, sorry to interrupt you. We already met with NZTA. They said they'll give us an exemption, so under certain parts of the Act, and it's just a matter of applying for that exemption. Thank you.
Okay, we've got a number of councillors left. If we can maybe just get one person perhaps responding from the team, that might help our time management here. So we've got Councillors Turner, Member Brown, Councillor Hills and Councillor Henderson to finish us off.
No, thank you. My question's been partly answered. Thank you.
Okay, Member Brown.
Thank you. Like others, excellent morning for these alternative transport systems, and have dealt with CRZJ, David Wang, in the past, and had really good interactions. Anyway, I just wanted to ask about the incline, just noting the terrain of Auckland. Could you give me like a hand gesture to the maximum incline that these vehicles can take? Because I saw it's sort of 15 over 1,000 or something.
So the bridge is like 6%, so we're talking 15%. But when they call say AW3, that's like crush loading. So that's like eight people per square metre. So that's pretty tight. So the difference between, we're saying 7.5 and 6.5 is effectively going from what you would find in New Zealand on a bus in terms of loading.
So it's
15%. And could start on 15% grade at a crush loading.
Okay.
That's what they're saying. That's what they're tested to.
Okay. No, thank you. Thank you.
Councillor Hills.
Thank you. Thank you for the presentation. What is the capacity of the 3-car?
So for 3 cars, the capacity will be 300 passengers.
Okay, and it's obviously far lower than light rail. Is that because of what's underneath? The space inside the carriages?
It's the length of the light rail.
Okay, but the inside looks quite a lot different. It's less as far as I can see, if you're looking at the two.
It is, in terms of square metres, it is slightly less, but it's modular between 3 to 4. So a 3 unit card is 30 metres long, and effectively a 4 is 39, which is equivalent to a double bus stop that we have operating on it's like Dinwiddie Road or.
Yeah. And what I've found on the website, it says the weight of the 3 is about 50 or 48, 50 tonnes full. That is more than double than our double deckers, so surely there would be infrastructure.
It's longer.
Yeah. Oh no, the spread is longer, but surely there would have to be some road changes that would need.
So yeah, that's one of the things that they want to determine. But my understanding from the work that we've initially done because we've been talking with them for a while, Rebecca, is that like in Shanghai, it's just a normal constructed road that are operating with existing services under the road. There's no real change, but it is a question, and one of the reasons they want to bring the vehicle over to answer that question.
Okay. And the last question, Chair. I understand on some routes, airport to others, but I couldn't understand why we would switch to something like this on Akaranga to Albany when 2 double-deckers are just a little bit lower than this in space-wise. Why would you switch to something that's...
So initially it was the reason that they're looking at is doing a trial, and we had a meeting with council. AT was actually looking at trialling it on the busway on a Sunday, and the other option was to trial it also within the North Harbour Stadium road network.
Okay.
And so it was effectively where they could have a trial location. And one of the questions of ours was, can you operate up to 70 kilometres an hour? That's a good location, like on a Sunday, that they could operate it.
Okay.
And show everyone that it does.
Yep. Councillor Henderson.
Thank you, Chair. So just forgive the basic question, but just so I'm getting my head around this, are we proposing to use this with general traffic, or does it need special lanes for this?
No, the current routes will be ready for the DRT to operate. The only thing we should do is we should install the magnetic nails for the DRT vehicles to follow. Yeah, I would also want to ask to answer further about the question why we should introduce this kind of system, because for one thing it is self-driving, and also it is driverless. So as far as I can know, that a lot of operators will be needed for the current bus operations, but for DRT, because there's no need for human to intervene, so it is manpower saving. That is one point. So the other point is from the point of the platforms and also the height of the entry part in the DRT. It is also more friendly for people with reduced mobility, and for another, it is also self-navigation. So which means that the DRT vehicles will just align with the current platform, so that people with reduced mobility are able to get on board the DRTs without any hindrance. Yes.
Sorry, just so that I've got that clear. Thank you, Chair. Sorry. So we're proposing to just put things in the existing road and to use it in general traffic. Is that right? So what would be the advantages if it's getting stuck in the same traffic as a bus would or any other mode?
Okay. So one thing, once you have the route, then the DRTs will be ready to operate. So which means that there will be almost no cost to the current infrastructure. That is one thing. For another, the lead time for DRT will also be very, very soon, because back to China, we already have the DRTs which are on the shelf. That is the second issue. The third one is also the operation cost will also be less compared with trams or metros. Yes.
Okay, so thank you very much for that excellent presentation. I guess, the key takeout from my perspective is that there's a willingness to do a trial here where, nothing ventured, nothing lost, and that a number of these matters, conceivably could be addressed, or would we certainly be a lot wiser than just looking at visual presentation. So we really appreciate that presentation. That's also gone to Auckland Transport. Councillor Simpson is going to move the recommendation of thanks, seconded by Councillor Fletcher. Similarly, with our previous presentation, we will now forward this to the relevant personnel within our organisation for their response. But two exciting presentations that obviously grasp the interest of the members here. So thank you again, and thank you people for some some really good questions there. So it's been moved and seconded. All those in favour? Against? Carried. Okay. Thank you, team. Yes, yeah. All right. With that ends, pretty meaty public input today, folks. So we move on to the local board input, which there is none. There's no extraordinary items, which brings us to the first item on the agenda, item 8, the NZTA